Alright, these are notes that are covering one-dimensional motion, and I'm going to touch on the metric system and significant figures quickly before we move on to one-dimensional motion. While viewing these video notes, you are going to need to write these notes down. These notes will be a grade. I will check them in class. They will be a participation grade. It's an easy 100. These notes won't last very long. I think they're going to run on average about 10 to 15 minutes. So that's not very long. Very much homework to do at night. Taking the videos, or viewing the videos and taking the notes. So I'm going to start with the metric system. Real quick. We have 3 dimensions to the metric system. We have mass, length, and volume. Of those 3 dimensions, we have what's called base units. The mass base unit is the grams. Length is the meter. Sorry about that. Volume is the liter. And then we use prefixes to move between the metric system. There are 6 that I'm going to want you to memorize. Mega, abbreviated a big M, a power of 10 to the 6th, which means it's got 6 zeros. So your conversion factor is a million. Kilo, little k, 10 to the 3rd, 1,000. Centi, little c, 10 to the minus 2, 2 zeros, your conversion factor is 100. Milli, 10 to the negative 3, 1,000. Micro, it's like a U with 2 tails on it, 10 to the minus 6, 6 zeros. Nano, little n, 10 to the minus 9, 9 zeros. See if I can fit them all on here. There you go. So your prefixes, your abbreviations, your power of 10, and your conversions. You'll need to memorize all of this right here. You'll need to know how to convert between units. So for example, if you have 1,018 meters, and you want to convert it to kilometers, we do what's called dimensional analysis. We want to bring down our unit to the bottom here. So the meter, we're converting to the kilometer. So we look over here, kilo, there's 1,000. The positive 3 indicates that the kilometer is bigger than the meter. So there's 1,000 meters in a kilometer. Our meters cancel out. We take 1,000, or 1,018, divided by 1,000. And we get 1.018 kilometers. You need to know how to use these conversion factors over here to go between the prefixes in the metric system. Alright, remember you can pause this video if you need to continue writing stuff down, but I'm going to move on. I'm going to move on to significant figures. On the AP test, you will need to use significant figures. You are allowed an error of 1 significant figure either way. You can either have 1 number greater than the amount of sig figs you should have had, or you can have one number less than the amount of sig figs you should have had. So let's just go over some ways to calculate and how many significant figures there would be. If you have 10.35 times 9.4, your answer would be 97 with a decimal. Because you only have 2 significant figures here, you have 4 here, so your answer can't have any more than your least precise, which is 2 significant figures. If you have 200 with a decimal divided by 1932, then your answer would need to have 3 significant figures because of the 200. There is a decimal here. The zeros that follow the 2 count. And so your answer is going to be 10.4. 3 significant figures, 3 significant figures. However, if you just have a whole number, let's say 200, no decimal, divided by 1932, we do not look at whole numbers. So we would use 4 figures for our significant figures, and our answer would be 10.35. Look at the last one. We have 0.00947 divided by 0.000135. Both of these have only 3 significant figures in them because leading zeros do not count. And so our answer would be 70.1 with 3 significant figures, 1, 2, 3, 1, 2, 3. Leading zeros do not count. Here, we didn't count these zeros. We consider this a whole number. We weren't going to look at whole numbers. Here, ending zeros or following zeros count if there's a decimal there. And you always use the measurement with the least amount of sig figs in your answer. That's just a little bit about significant figures. I'm going to go on into one-dimensional motion now. The first thing that we want to talk about is displacement and distance. The difference between distance and displacement is, let's say that you use the sidewalks to walk around the school. And you start from the science building and you walk to the 200 hall, and then you walk from the 200 hall by the library to the 300 hall, and then you walk from the 300 hall over to the 400 hall, and then to the band hall. Now, you've covered a lot of distance there. So distance is the amount of, let's say, your steps taken. However, displacement would only be measured from point A, which is the science hall, to point B, which is the band hall, in a straight line. So your distance that you took using the sidewalks all the way around to the band hall is going to be greater than your displacement was, because we're going to measure displacement from point A to point B in a straight line. The next thing we need to talk about is the difference between speed and velocity. Speed is the distance traveled over the amount of time it takes to get there. Velocity is the displacement. over time. Speed only shows magnitude. That's the amount. The amount of steps you took. Displacement, or I'm sorry, velocity, shows magnitude and direction. So velocity is a vector. Anything that shows direction is a vector. Acceleration is velocity over time. Since velocity is a vector, acceleration is going to be a vector, which shows magnitude and direction. Now, when we talk about motion in one direction, we're talking about motion in either the x direction or the y direction, but it does not combine. We're not going to combine x and y until we get into two-dimensional motion. We're not going to do that yet, not until next week. We have 5 equations that we have started labeling the big 5. 5 equations to help us with one-dimensional motion. The first one is change of x equals vt. The second one, v equals v naught plus at. Then we have x equals x naught plus v naught t plus 1/2 at squared. Number 4, x equals x naught plus vt minus 1/2 at squared. V squared is the 5th one, equals v naught squared plus 2a x minus x naught. I need you to memorize these. You will be able to use a formula chart on your AP test, but you're going to have to go so fast that you're not going to have time to look these all up in order to get finished. So I am going to require that you memorize some formulas. So let me show you how some of these work. Again, you can pause this to write these down. My first example, and I'm just going to abbreviate, I have a car initially traveling 10 meters per second. It accelerates for 4 seconds at a rate of 2 meters per second squared. In a straight line. That's going to tell us that it's one-dimensional motion. How far does it travel? Whenever I do kinematics problems, I like to circle what I'm given, underline what I'm looking for, and then write my variables down. There's 10 meters per second, 4 seconds, 2 meters per second squared. How far? And I'm going to write my variables down. This 10 meters per second means velocity. It says it's initial. So that means V naught is going to be 10 meters per second. My time is 4 seconds. My acceleration, meters per second squared, tells me its acceleration is 2 meters per second squared. And I'm looking for X. So as I look for, and I can assume that X naught is 0. As I look for formulas, I want to look for a formula that has all of these things right here. So there's going to have to be things that you're going to have to assume. I'm going to go with formula 3, X equals X naught plus V naught, change of t, plus 1/2 AT squared. I have X, I have X naught, I have V naught, I have T, I have A, and I have T. X is what I'm looking for. So I'm just going to plug these in. That's going to go to 0. I assumed that. So I'm going to have 10 times 4 plus 1/2 times 2 times 4 squared. So I plug all this into the calculator, and X equals 56 meters. Let me do one more example for you. Number 2. I have a baseball thrown up with initial speed of 20 meters per second. How high will it go? So, this is going to be working in the Y direction. Going up, Y direction. The other one was in the X direction. So again, I circle what I'm given and underline what I'm looking for. I'm going to write my variables down. I have V naught equals 20 meters per second. Because I know I'm working in the Y direction, I know that gravity is involved here. And gravity is my A. So gravity equals, we're going to use 10 in AP Physics for gravity. So gravity equals 10 meters per second square. I'm looking for, I know my Y naught is going to be equal to 0 because it was thrown straight upward, so I'm assuming that. So whoever was holding it at the ground level or close to the ground level, and I'm looking for Y. How high will it go? So I'm going to look at my formulas and find something that I have most of these things with. I can also assume that when it gets up to the top here, that my velocity right before it stops and heads back down to the ground is going to be equal to 0. So that's another assumption I can make. So I look at these formulas, and I'm going to use formula number 5. V squared equals V naught squared plus 2a x minus x naught. This is how it was written as I gave you. But see these x's right here? They can just as easily be written as y's. This a right here can be written as g. Y minus y naught. My v here, 0. Goes to 0. My y naught is 0. So now I'm left with 0 equals v naught squared plus 2gy. And I am solving for y, so I'm going to have to manipulate this formula. I'm going to move v naught squared over to the other side by subtraction. So I'm going to have minus v naught squared equals 2gy. And then I'm going to move 2g by division. And I end up with, and I can switch places here, I end up with y equals minus v naught squared over 2g. I can then plug in my numbers. So I have minus 20 squared divided by 2. And again, I'm going to use 10. And I'm going to have to use negative 10 here. And I plug in my numbers. And I get 20 meters. So that baseball goes up 20 meters. As I'm looking at these notes on the screen, I can see that they're a little bit light using my pencil. I think that you can read them if you're on a full screen. I will try to use a darker pen from now on. So these are your notes for September 2nd. Please take notes and bring them to class to get them checked. Thank you.